We're going to now take a look at the last category of compounds that we need to have a nomenclature system for, and that is acid nomenclature. We recognize immediately that a compound falls in the acid category because its formula will begin with hydrogen. Notice that most acids are usually found dissolved in water as a solution, so we indicate with a subscript AQ, indicating aqueous or dissolved in water. In Chem 2A, we're jumping ahead to section 11.1 in chapter 11, which introduces acid-base chemistry and nomenclature for acids at that time, but we really kind of need it now. So we're just going to reach ahead into section 11.1 and talk about acid nomenclature right now, while we are also looking at how to name ionic and molecular compounds. In Chem 22, this information is found in section 5.9 of chapter 5. Notice that we make acids. One way of viewing how to make an acid is by adding hydrogen ions to anions, negatively charged ions, until we produce a neutral compound. So illustrating that with the carbonate anion. -2 charge on the carbonate, it's certainly going to attract a positive hydrogen ion, and if hydrogen binds to the carbonate ion, we form a new ion, the hydrogen carbonate ion, HCO3-, and this ion is listed on the anion sheet that you need to memorize. Notice that there's an older name for this ion, the bicarbonate ion, but the hydrogen carbonate name is preferred. This hydrogen carbonate ion still has a negative charge to it, so it can attract another hydrogen ion, and now we produce a neutral compound, H2CO3. It has no net charge, it's neutral, its formula begins with hydrogen, and we're going to categorize that as an acid and put a little AQ with it. We find this acid in an aqueous solution. That's what the AQ indicates, aqueous or dissolved in water. Here is the key idea when you look at naming an acid. You have to be able to identify the anion present in the acid, and you have to be able to properly name that anion. And it's the suffix ending of the anion name that determines how the acid itself will be named. So you have to look at an acid, identify the anion in it. In this instance, the anion that is present in this acid, and let's make that pop, is the carbonate anion. So how would we name this acid that contains the carbonate anion? Well, let's take a look at the system developed to do that. So we recall that anions either end in "ide" or "ite" or "ate," the name of an anion. So looking at the first category, anions that are ending in "ide," and these are typically monatomic or single atom anions. If the anion in the acid ends in "ide," then we're going to name the acid itself by including a hydro prefix and an "ic" suffix with part of the name of the anion. And let's illustrate that with this first acid, HCl. Looking at the acid, I've highlighted the Cl-1 anion present in the acid. And notice, because chloride has a -1 charge, it will attract only one +1 hydrogen ion to form a neutral compound. So you can predict that the formula of an acid containing the chloride ion is HCl, because the -1 charge on chloride means that it can only accept one hydrogen ion to form a neutral compound. Once this neutral acid has formed, HCl, how do you name it? Well, we're going to use the hydro prefix plus a portion of the name of the chloride anion, the chlor part, and then attach the ic suffix. So we would call HCl hydrochloric acid. Let's do a second example. A companion of chlorine in the halogen family is bromine. And when bromide forms an anion, we predict it to have a -1 charge. So bromide, again, a -1 anion, attracting a single hydrogen ion to form a neutral compound. So how would you name the acid with the formula HBr? Well, you look and recognize that the bromide anion is present in the acid. The anion ends in "ide", so the acid will have a hydro prefix and an ic suffix, and the name of the acid will be hydrobromic acid. Hydro prefix, part of the name of the anion, and an ic suffix. Let's move to the second category of anions, those ending in "ite". If you identify that an anion in an acid ends in "ite", the way you name the acid is by just using a suffix and ending of "us", O-U-S. No prefix needed here. So let's take a look at a couple of examples. Looking at the acid HNO2, I identify by highlighting that the nitrite ion is present in the acid HNO2. And it's a good time to stop here and remind you that chemistry and its concepts are very closely linked together. If you don't know the names of the anions that we looked at in the discussion of ionic nomenclature, then it's going to be really difficult to transfer that information and apply it to acid nomenclature. So you really have to memorize that table of ions needed to be able to name ionic compounds. So back to the name of HNO2. We recognize, hopefully, that there is the nitrite anion present in that acid. Nitrite ends with the suffix ITE. The acid will end in OUS using a portion of the anion name. So here we have nitrous acid. The nitra from the anion nitrite, and the us, the suffix ending. Let's do one more example, this time involving the anion sulfite. Because sulfite has a -2 charge to it, then we are going to have to bond 2 hydrogen ions to the sulfite anion in order to make a neutral compound, an acid. So how do we name the acid that contains the sulfite anion? This is a little tricky here because we're not just going to call it sulfus acid. In other words, we're not just going to drop the ite off of sulfite and add OUS. Sulfus sounds kind of funky. So we're going to use the name of the element sulfur, it is a sulfur oxyanion, and call this acid sulfur, and then there is the OUS ending, sulfurous acid, containing the sulfite anion. Last category of anions that we need to look at are anions ending in "ate". If the anion name ends in "ate", then the acid name will end with the suffix "ic". No prefix involved. So looking at the nitrate anion, the partner to the nitrite anion, another nitrogen oxyanion, the nitrate anion ends in "ate". So we're going to drop that "ate" ending off of nitrate when we form the acid by adding 1 hydrogen ion based on the fact that nitrate has a -1 charge. So the acid formula, HNO3, will be named nitric acid, dropping the "ate" off of nitrate and using the "ic" suffix for the acid, nitric acid. Looking at the second example, I see the sulfate anion, the companion to sulfite or partner of sulfite, another sulfur oxyanion. Its charge is -2, so we need 2 hydrogen ions to bond to it to form a neutral molecule. How do we name an acid containing the sulfate anion? We drop the 8 off of sulfate and add the ic suffix for the acid, so this is sulfuric acid. And both nitric acid and sulfuric acid are very important industrial or commercial acids. They are used widely in industry, both nitric acid and sulfuric acid. And now for our last example, going back to the acid that we formed here right at the beginning, looking at the formula and recognizing that it contains the carbonate anion, H2CO3. How will we name the acid? If the carbonate anion ends in 8, we're going to drop that 8 ending off of the anion and refer to the acid formed containing it as carbonic acid. Carbonic acid containing the carbonate anion. And carbonic acid is a very important biological acid.